everyone, welcome to today's class. In today's class, we are going to be talking about the centroid of a shape, centroid of an area. It might not be an area, it might be a combination of areas. So in this case, we have a plane figure that we want to determine the centroid. Centroid is similar to center of gravity. When you say center of gravity, we all know that center of gravity is a point at which the entire mass of a body is assumed to be concentrated. Not that the entire mass is concentrated there, we only assume at that point we have more of the mass. The mass of a body is distributed uniformly depending on how the shape is. But there is always a certain point that normally have the highest mass, which is what we call, that point is what we call center of gravity. But in this case, we are dealing with a plane shape, an area of a plane shape. When you place a body on the floor, the area of the floor that body will occupy is what we mean by plane. The plane shape, the area of that point of that body, meaning the base of it. So now this diagram we have here is obtained from the shape is obtained from a body that is placed on the floor. So we have to determine the centroid of this plane figure. But as you can see, we notice that this plane figure has different regular shapes. You can see here we have a rectangle, which I named A. Here we also have a rectangle. We have a semicircle here. We have a triangle here, and we also have a rectangle here. So in order to determine the centroid of this entire shape, we have to find the center of each of this section, the center of each of this shape. At the same time, we are going to find the areas of all these shapes separately. Then we combine them together to obtain our centroid. So how do we go about it? Now let's start. Firstly, we are going to start by introducing the formula. So this is the formula for the moments of the area of each of this shape. We are going to determine the area of each of this shape and at the same time find the moment, meaning that to get the moment we have to determine the distance at which the center of each of this shape is situated to any reference point that we are going to be using. So this is the formula, the area of A, figure shape A, and the center of gravity of this A. Same goes to B, same goes to C, D, and E. So the same thing we are going to do in the as we are doing it for the x-axis, we are going to do it for the y-axis. So without wasting time, let's go straight to the solution. Now, to go to the solution, we have to, let me introduce you to what all these terms mean. Like the A means the area of each section. Then the X means the distance, center distance along x-axis of each section. Then the Y means the distance or the center distance along y-axis of each section. Then this bar Y, this capital Y, means the main center distance along y-axis. Main means the entire shape. Then the bar X means the main center distance along x-axis. Now to start with our solution, we are going to determine the area for each of this shape. For shape A, which is a rectangle, as we can see it, this A is a rectangle. So we are going to have the area to be A equals to length times breadth. So what is the length here? The length is 4, as you can see. The entire length 4 times the breadth 0.5. So that is how we have it to be 4 times 0.5, which is 2 meters. Then the distance of that shape, the center distance of that shape, which is this one, x-axis. This point is x, y, this point is y. And sorry, this axis is y, this axis is x. Now we have to determine the center of this shape alone, which means that the breadth is, this is the breadth of that rectangle, so it means the breadth divided by 2. So what is the breadth? 0.5. So that is how we have this 0.5 divided by 2, and we have this. Same goes to the y. This is the y part of it, the y axis. We are also going to determine the center of this y, and the entire length here is 4. The length is 4, so the center is going to be L divided by 2, which is how we obtain this L divided by 2, which is 4 divided by 2 to get 2 meters. So same goes for shape B, which is also a rectangle. The area is length times breadth, which is 2.5 times 0.5, we get this. Then the distance, center distance of the x-axis is L over 2, which is 2.5 divided by 2. Same for the y, B divided by 2. For shape C, which is the semicircle, so same goes for it. The area of a semicircle is pi r square over 2. So while using the formula, we obtain this. Then the distance, x, this x-axis of it, the x-axis of it. So the center of this semicircle is going to be the diameter divided by 2, which is what we use here. The diameter divided by 2, you get 1.25. Then for the y part of it, this is the y. Looking at it here, this. So to get the y part of it, looking at it here, this is the y. This vertical. So to get the y part of it, the formula is what? 2d all over 3 pi. 2d all over 3 pi, which is equals to this. Then same goes to shape D, which is the triangle. We all know the area of a triangle is half base times height. We have this, and the distance of it. Looking at it here, you can see distance of the x. This is what? The base, and the base is what? 2.5, as we have it. You can see it here, 2.5. So 2.5 divided by 2, so we obtain it to be what? 1.25. Then the b, the base, the distance on the x-axis is 2.5 divided by 2, sorry, that is 1.25. Then the y-axis of it, this part, this is the y. We want to determine the center from the base to the highest point, the vertical axis. This is the vertical axis of it. To get the what? The center of this. So we are going to what? We are going to use h all over what? H all over 3. You can see h all over 3. So, and this h is 1 divided by 3. We have this. Same goes for shape E, which is also a rectangle. So if after arriving at that, so we move to the summation. We are going to move to the moments. We are going to take moments of all this shape with respect to the what? The axis. Now starting with y-axis, we are going to take moment about y to get x. Before we can get the moment for x-axis, we are going to assume a reference point from y, meaning that our y-axis will serve as our reference point. So to get our moment for all x. Now how do we go about that? Okay, this is the formula. This is the area times the distance of that shape to the y-axis, sorry. the area multiplied by the distance of that shape to the what? To the y-axis. For example, we have this. This is the shape. This is the x-axis. The center of this axis to what? To this reference point. This is the reference point. The y-axis is the reference point. So we are going to use the distance from here, center of here. The whole, this rectangle is acting at the center. The centroid of this rectangle is at this center. So we are now going to say the area multiplied by this distance. For E is going to be the center here multiplied by the whole distance here. Same goes for others. Now let's start. In this aspect now, the area for what? For the first shape, which is the rectangle, is what? 2, as we have obtained it here. You can see the area is 2. Then the distance is equal to 0.25, which is what? Half of this 0.5. 0.25 multiplied by what? This point to this point. The area, which is what? The area which is 2 multiplied by what? The area which is 2 multiplied by the distance. The distance is 0.25. Here to here is 0.25, which is what we have obtained here. The same thing goes for shape B. The area is 1.25. If you check, the area is 1.25 for B. You can see 1.25 multiplied by the what? The center. The center is 1.75. 1.75 center. That is the center of shape B to the what? To the y-axis. This is shape B. This shape B. This is the center. Half of 2.5 is what? 1.25, isn't it? From here, you have to be very careful when you are calculating it. Here to this place is 1.25, but we are coming here, meaning that here to here 1.25 plus 0.5. That is what? That is 1.75. So meaning that here to here to this y-axis is 1.75. So that means we are going to be using what? Our area, which is 1.25, to multiply 1.75 to get the moment for shape B. Same goes for shape C. The area is 2.454, as you obtain it here. 2.454 multiplied by the center distance of that shape. This is C. This is the center as well. Center for C. Here to what? We are multiplying, we are adding here to here plus this place, which is 1.25 plus 0.5, just like this rectangle here. So we have it to be same as 1.75, just like this. Same goes to shape D. Shape D, distance of here plus here. Same goes to E, distance of here to here. So that is how we obtain this 1.25 and 1.75. 1.25 times 1.75 for x. So while adding the sum, while adding them together, we have 11.3585. Now, taking moment about x to get y. This is more complex than the first one we did. We want to take moment of x. We want to take moment about x to get our y. If we obtain our x here, we take moment about y to get x here. But here, we are taking moment about x to get y. Just the way we did the first one. But here, our reference point is going to be x in this point, because we are calculating for y. Now, our normal, as we all know that all our areas are still the same area that we use here. So which is 2, 1.25, all these areas. What only change is this our distance. Now, how do we obtain that? YA, meaning that the first shape, look at the first shape here. This is the y we want to get, the center of this y. Center of this y. Looking at this y now. So this, where is the center? The center, this is the center of y. which is what? The center of y. So from here to this place is what? Here. This is the center of the y. So we are coming to the direction of x-axis. So this is the center of this rectangle. This is the center. So from here to here is 2. That is how we obtain this 2 times 2. Then here to get this 3.75 for the second rectangle. Now look at the center here. The center here. Here we already know that this here is 0.5. Then half of it is what? 1. Half of it is 0.25. Half of 0.5 is 0.2. This is the center here. Always use the y-axis here. Now, once you get the center here, now what is the distance of the center down to x? Which is 0.25 plus this place down. You already know that if this is 0.5, then here to here will be 3.5. Then 0.25 plus 0.5, we obtain it to be what? That will give us what? That will give us 3.75. This 3.5 already, then plus 0.25. So we have what? 3.75. That is how we get this. Now for this, which is the C. Now let's look at this C. It's more complex. The whole of this place is what? Here to this place is what? 3.5, isn't it? Then the formula for the distance of this is what? Don't forget here, we have the formula for the y to be 2d all over what? 3 pi. 2d all over 3 pi. Meaning that from here to this place, here to this place, we are going to find something like this for it. 2d 3 pi. This is the diameter. Diameter is 2.5 multiplied by 2, which is 5, divided by 3 pi. So whatever we get here, we are going to subtract it from 3.5. Here to here. Here to here is 3.5. So if we use the formula to get the distance, so whatever we get, we're going to remove it from here. It's going to be the what? The center of this semicircle. So from here now downward is going to be the distance we are using. The area is going to be from here times what? Times it's going to be the area of this multiplied by the distance from here to here, which is what we obtain to be what? Our 2.969. You can see it here, 2.969. So same goes to our D, which is this. From here to here is what we have calculated for, which is the center. The center of the centroid of this shape in y along y-axis is going to be somewhere here. So we obtain that by using what? H all over 3. Our h over 3 is 1 over 3, which is somewhere here. Then the remaining from here to here is the distance we are using, because our reference point is x. It's going to be from here down to this place. So which is how we obtain this 0.833. Then for the last part of it, which is the last shape E. So here the center of this shape here in the y-axis is 0.25 to this axis. Here to here is going to be 0.25, which is why we use 0.25 here. So after doing that, we do our normal addition. So we obtain our moment for all the y-axis to be 15.4892. Then we add all our areas together. All the areas we have calculated for here, we add all of them together. So to get this, Then we can now find our what? Our x, our main x, which is the summation of all the moments on the x-axis over all the areas. Summation of all the areas, we get this. And also summation of all the what? Summation of all the moments along our y-axis all over summation of all the area. Then we get this. Meaning that this bar y and bar x are the center of what? Of the whole shape here. Now what do we get for our bar x? 1.385. 1.385 for our x. From here, we're going to mention 1.385 here. So whatever we get here, then for y as well, we're going to mention 2.112 from here upward. 2.112. Whatever the point to reach, we trace them out, and determine the point. That point is what we call our centroid. So that is how to obtain centroid of a plane shape. Sorry for any inconvenience, or maybe not too fast, or not doing it to your satisfaction. Thank you. We shall meet in the next class.